Hi, welcome to class. I'm going to be actually working on the floor so I can get this videotaped. Okay, this is lecture 8.5. We're going to be talking about annuities. Annuity. Okay, here's definition of an annuity that I came up with. It's an investment account where the deposit of money, I'm just going to do shorthand for money, is made consistently. That means at the end of each compounding period. At the end of each compounding period. Okay, I'll give you a moment to write that. So an annuity is an investment account where the deposit of money is made consistently at the end of each compounding period. Okay, so it's like you make a once a month deposit. So I'm just going to use that as an example. We deposit $100 once a month. So this is different from our other things that we've been looking at where we deposit once and our money grows. In this case, we keep depositing once a month or twice a year or once every 3 months. Okay, so here's the annuity formula. It's pretty big, so leave room on your paper. And it is A equals P, and then put brackets, parentheses, 1 plus R over N to the NT minus 1. Don't forget that minus 1 in there when you're calculating. All over R over N. So I'll let you write that down. Okay. If we deposit once a month, then N equals 12. Okay? If we deposit every 6 months, then that's going to be twice a year, right? So N equals 2. Okay, so I'm going to erase this board and keep writing on the lecture. We're going to do an example now. Okay, so the example. Deposit $200 once a month at 3.25%. That's the interest rate for 10 years. Okay, so letter A, what is the value after 10 years? Okay, I'll let you write that down. Okay. All right, so what's the value after 10 years? Since we are depositing once a month. That is our clue that we're looking at an annuity. Okay, so off to the side, we're going to put our letters A, P, R, N, and T. Okay, now this is going to get kind of messy in writing, so write small, and you'll need your calculators as well. All right, so the question is, what is the value after 10 years? So that's what we're looking for. We put the question mark there. All right, P. What does P stand for? Well, P is the deposit that we make, and we're making a deposit once a month of $200. The rate is 3.25%. Remember, we have to move that over 2 to the left. That's 0.0325. Now, N, it says once a month, so N's going to be 12. That's 12 times a year. And T is 10 for 10 years. Okay, so let's write up using our formula. We're looking for A. We put in our P into our formula that we wrote down. Okay, 1 plus 0.0325 all over 12 to the power of 12 times 10. And remember, don't forget to minus that 1. Okay, now all of that goes over R over N, and that's 0.0325 over N, which is 12. Okay, so using our calculator, we would do what PEMDAS says to do, and that is work in parentheses first. Well, we do exponents. So our exponent here would be 120. So off to the side, I'm just going to note that's 120, so I don't have to put it into my calculator. So in my calculator, we would go 0.0325 divided by 12 equals plus 1 equals. So in doing that, and we don't want to have round off errors, so we put in all the numbers that are in our calculator, which is 1.00270,833, and all of that's going to go to the power of 120. Okay, and then don't forget minus that 1. All right, and then all of that is over. If we put in our calculator 0.0325 divided by 12, we'll get 0.00270,833. All right, so continuing, we do what's in the brackets. So we're going to do this first and then minus our 1. Okay, so we have 200, and I already did that for you. That ends up being 0.383422759. Okay, and then again, that is all over 0.00270,833. Okay, so what are we going to do now? We're going to take this and multiply it by this and divide by that. Okay, and when we do that, so we do the numerator first, we leave all the numbers in our calculator, then divide by the denominator, and we end up with, well, here's the numerator, 76.68455,189 all over 0.00270,833, and our final amount after 10 years is going to be $28,000, 314 and 33 cents. Okay, I'll let you copy that for a little bit before I erase it. Okay, so we know how much was made depositing $200 for 10 years. What if we went on to know how much interest did we make? So we're going to calculate how much interest was made. Okay, so let me write that question. This would be part B. How much interest was earned? How much interest was earned or made, however you want to put it. Okay, well, our total we said came out to $28,000, 314 and 23 cents. Now to find out how much interest we made, we're going to minus all the money we put in. Well, we put in $200 a month. We have 12 months. And we did that for 10 years. Okay. So again, that's 28,000. And we're going to minus $200 a month times 120 months. Because there's 12 months, 10 years is 120 months. Okay. Now that ends up being $24,000 that we had deposited in 10 years. So we subtract that amount and we end up with $4,314.23. This was the amount of interest that was earned. Interest earned. Looks like an O, it's actually an A. Okay. Okay, very good. Now I'm going to erase this because I have a lot to write for the next problem. And then we're almost done with this lecture. It went pretty quick. Okay, so here's another example of a different type of problem. And it is, how much do we need to deposit? How much do we need to deposit monthly into the same account we were talking about? To have $40,000 after 10 years. Okay, I'll read that again while you're writing it. How much do we need to deposit monthly into the same account to have $40,000 after 10 years? Okay, so we're still depositing monthly, so we know we're using the annuity. It's the same account. So what we go off and do to the side is we put our A and our P, our R, N, and T. And now we look at the words and we put in what we do know. We put the question mark, what we're looking for. Well, let's read it again. How much do we need to deposit? That's what we're looking for. So P is our question mark. Into the same account to have $40,000 after 10 years. So A is going to be $40,000. Okay, so our rate's going to be the same, which is 0.0325. Our N is going to be the same at 12, and our time is for 10 years. Okay, so we're going to use the same formula. We're just going to fill in different letters. So right away we know A is 40,000, and that's going to equal our formula, but this time we don't know what P is. So P is our variable that we're looking for. Okay, so we have 1 plus 0.0325 over 12 to the 12 times 10 minus 1 all over 0.0325 divided by 12. Okay, now lucky for us, we've already calculated this all out, so I'm going to go ahead and write down what we came up with in the previous problem. That'll save some time.